For this series of videos on rotations, I encourage you again to watch the video on rotations before looking at these examples. If you have watched that video, I'll make a start. State the order of rotational symmetry of each of these following shapes. So if I spin this around, I take the midpoint here. Let's change the settings a little bit so I can draw on it. So the center of the shape is here, and if I spun the square around this middle point, it would be the same 4 times. This point would rotate to here, and then to here, then to here, and then back to here again. So this has a rotational order of 4. B is difficult to see here, but I'll just outline it. A rectangle, in the same as the video before, if I took the midpoint and rotated it around, it's only going to be the same twice in 360 degrees. And finally this one, even though it looks like it should have some rotational symmetry, it does have reflectional symmetry. It's the same either side of this line here, but if I were to try to spin it around the midpoint, which could be about here somewhere, it's not going to be the same at all until it gets back to the original position. So this has a rotational order of 1. In example 2 now, it says the corners of a rectangle have these coordinates, and you can see on the diagram, if I were to highlight that, it's going to be 3, 2. Oh, hasn't. This is actually a triangle, isn't it? I find it difficult to see. I'm going to use the same grid here with a different shape. I'm going to use a brighter colour, maybe yellow. I'm going to draw this rectangle then. 3, 2, so 3, 2 is here. 7, 2 would make here. 7, 5 would be here. And 3, 5 would be here. And it says the rectangle is to be rotated 90 degrees clockwise. Remember, clocks go this way round. About the origin, which means I have to look at where the origin is, and I would spin it around that point. So if I scroll down a little bit, you can see that the origin is this point here. The easiest way to do this is with tracing paper, but you could also just do it by eye. If you did it by tracing paper, there's a small diagram here to explain how you do it. So if my shape was the rectangle from here, for example, which is where what the example rectangle is, I would draw that on my tracing paper, and I'd put the pencil at the point where I'm spinning it, which would be here. So I put the pencil on that point, and then, as you can see here, the arrow, I'd rotate it 90 degrees. I would also encourage you, when you're drawing your shape on the tracing paper, to make the tracing paper in line with the grid, because then when you rotate the paper, you stop when this line is now going in this direction. So it's always easier if you draw your shape on a piece of paper that is in line with the actual grid lines itself. When you spin it around, you see where it goes. You can draw the shape. But if you wanted to do that without using tracing paper, you could count squares again. So you count 1, 2, 3 across, and 1, 2 up, and that sort of gives you an L shape. And if you spin that L shape around, it's going to go 3 down and 2 across. So the new point would be here. So this point has rotated to here. And you could do the same with all of these. If you drew another L shape with a different colour, so do light blue, to go across we would count 7 squares and 2, and then to go down we would count 7 squares down and then 2 across, which would make it here. So you can see that you can still do it even if you don't have tracing paper. The yellow is now the yellow, the blue is now the blue, this is the blue one here. I could do another one in red, see. Let's do this one in red. That would be 3 across and 5 up. So 3 across and 5 up. And if I spun it round, I go 3 down and then 5 across, which would make it here. And then after now I've got 3 coordinates, I know the other one's just going to be here. I don't really have to do it with that coordinate. I can just look at it, look at where my other points are, and then draw my rectangle. Easy.